Hello students, in continuation with the previous topic, that is a fault tolerance, we are going to discuss about the process resilience. See, before entering into the topic, we should know what are the outline we are going to discuss for the day. See, first one we are knowing about the process resilience one. Next, we are going to know about the flat and hierarchical grouping purpose. Next, to maintain this resilience, what is the agreement we are going to maintain over there? The name of the agreement is a Byzantine agreement, and at last we are going to analyze the detection of the failures. So this is the outline we are going to discuss for the day. Now, as we are entering into the main topic, that is the process resilience. See here, first of all we should know what is a fault as per the previous topic. See, fault is nothing but your system will be, actions of your system will be in a different way, and your internal system behavior will be in a different way, and incorrect internal state of your system. So that may be any kind of fault it may have. Now coming to the examples, as we discussed, your database may be slowed down, your memory leaks may happen, a particular thread may be not available to us at all. So all this kind. Now what is a failure? The consequence of the fault is nothing but the failure. Now if there is a failure, our system will not do its job correctly. Right. Now resilience. Now coming to the resilience, is nothing but it will prevent your system to enter from fault to the failure. So the intermediate part where the fault occurring and the failure is about to occur. So the mediator part is the resilience part. Right? It is about preventing faults turning into the failure. Now in how many ways we can make that to stop from failure to the, from fault to the failure. Once failure occurs means our system is not in a proper state to behave, and that may be not perform our task whatever we have done. So when it is under fault detection itself, then we can analyze what to do for that fault to make our system to be safe from the failure. So that is a procedure mechanism we do in the resilience part. Now coming to the actions we are going to take care are, we are going to concentrate on the processes which we have in our hands. If a process, if we are having a group of processes, if there is one process which is faulty, then and there itself we have to analyze that there is a faulty process, and then we have to repair it or replace it, or else we have to stop that, kill that, and you start procedure with other processes. So that is one of the process grouping which we have. Second one is, if we are having one value, all the processes in the group must maintain the same value, that is identical. So identical is nothing but, if I am performing a task 1, same like me, there should be another process which is performing same task, that is task 1. So if I am getting into the fault thing, this process has to take the action, it has to execute immediately. So that is what the procedure is saying. The task whatever we are performing is the only one. If any fault process is occurring in between, we have to take care of that, and immediately we should be able to function without disturbing the environment. So that is the procedure which we are going to do in the process resilience. See, now here we have two types of grouping as we have discussed just now. Here we have 5 processes, here we have 5 processes. In the flat group, each and every system will be a peer entity. There will be no concept of client and server, right? So thus there will be no coordinator kind of thing. Every process has right to take the decision, and every process can behave as it can be taking into the, it's as a coordinator. So if this is a coordinator, if at one time a process has been removed, immediately all the remaining 4 processes will be getting some hectic task to analyze which process has been under faulty part. Now coming to the hierarchical, here always server or else the, depending on the election algorithms, a process will be called as a coordinator, remaining all processes will be called as a workers, right? Now if a coordinator is there, if there are n number of processes connected to the coordinator, if one process fails, Coordinator will inform to all the process, all the workers in the team. Thus, we can know the process, faulty process to the coordinator immediately. So this is an easy process compared to the faulty process, right? Now these are under the process grouping. So first of all, we have to select an coordinator, then keep on updating with our values whatever we are doing. If there are n number of tasks to perform, divide the task among the workers, and we have to keep on updating our values to each other. I mean, the process, there are 5 processes. 5 processes should be acting in an identical way. That is what we have discussed in the synchronization part. Now, what is the agreement we are going to maintain to maintain this resilience part is the next procedure. Now, in this, we are going to concentrate on the distributed databases systems. See, if a distributed database system is available to us, there are n number of processes. We should know whether to commit this or else whether to abort this process depending on the faulty process. Next, if our system is under mutual trust, how to take the agreement is the next part. If our system is under agreement procedure, how come we can understand there is a faulty system, right? If failure occurs, processes must exchange their value within the other processes. So if there is one, as we discussed, there is one process which is a faulty type. So before entering into failure status, we should analyze the remaining processes should be having the knowledge of the faulty process first of all. So see, agreement protocol should be enabled at that moment to make the presence of the failures to everyone. Now here, what is the algorithm saying, Byzantine algorithm? So the main objective of the Byzantine algorithm is to make all the processes agree on a value. So what is that value? If there are 5 processes are working on one value, right? So the working of the algorithm we are going to see now. So let us assume there are 4 processes and there is one faulty process. Now how we are going to make these processes as readily available to us? See, when we have one process over there, one is giving same value to everyone, that is 1 1 1, identical value. Now 2 is giving its value in the green format, that is 2 2 2. Now 4 is also giving in the yellow, that is 4 4. Now what about 3? It is not giving its values genuinely. So that is what the term loyal generals and the traitors. So here 3 will be called as a traitor because it is not giving the correct values at all. Loyal generals are nothing but 1, 2 and 4, right? So here every time as a step 1, all the processes which are there, one is reporting with all other, each and every other processes in the list. 2 is also behaving in a similar way, right? Now, as we have just seen, there is a faulty process 3 which is not giving the correct value. It is about to give some values, but those values are not same. See, can you see X, Y and Z somewhere? Okay. 1 is giving the identical value, 2 is giving the identical, 4 is giving the identical, but 3 is not giving that way. 3 is giving some X, Y, Z values which are not correct. So then and there itself we can say that there is a faulty processor over there, so that every other process which is connected to this can understand that 3 is a faulty process, right? So these are the steps whatever we have seen just now, right? So when we have the final point, so this final point will be giving us the X value as, I mean the 3's X value as some other X, Y, Z. So immediately we are going to say that you have some faulty process which is unknown to us. Okay, so when we have unknown, so then and there itself that 3 is a faulty process, so we can understand that 3 will be the faulty one, right? So that is what we are mentioning, that as an unknown in the result. So the result should be correctly given that the traitor was 3 process. So that is what the Byzantine agreement algorithm for the faulty, identifying the faulty system. Now the last part of this is a failure detection. So how we are knowing the failure detection in the database kinds. I mean, if we are concentrating on the processes, how we are doing that. If we are concentrating on the databases, how we are doing that. So everything in the systems we call as a process, right? Now, each and every time we will call in the two ways. First is actively, second is passively. When I am calling the processes actively, I will be keep on asking all the processes, are you alive? Once I get the result, the process is live. If any process is not giving the result, we can say that that process is dead. Similarly, second type is nothing but passive. So passive is nothing but we are going to give one message. Okay, so if I am asking, say please wait until you get a message from the process. So there are 5 processes. 4 processes gave some message. 5th process did not give. So that we can't judge that it is dead. We can't say that it is dead, right? So this is a good way, but sometimes even though the process is alive also, we can say that that is dead because it is not giving any message. We are waiting for that, but it is not giving. So these are the failure detection procedures we have. If you have any doubts in this, please be free to contact anytime through college.